Hello everyone, this is Abha Tewari and welcome to the Data Engineering series. In today's tutorial, we will explore NoSQL database with Neo4j, a powerful graph-based database system. Before we begin, make sure you have a Neo4j account or Neo4j Desktop. Either option will work. So let's get started.
But what is Neo4j? Well, Neo4j is a cloud-based, fully managed version of graph database. It stores data in the form of graph data structure. To query data in Neo4j, we use Cypher Query Language. It lets you store, query, visualize corrected data without managing the infrastructure. The key features of Neo4j are: it is fully managed, no need to install or maintain server, high availability, automatic failover and backup, scalability, handles increasing data and traffic easily, it is secure. Cypher Query Language is easy to write, easy to model. Neo4j gets integrated with different programming languages like Python, Java, Spark, and Graph Query Language. Neo4j provides different tools for managing, exploring, and querying your graph data. There are certain tools in Neo4j: Cypher Query, Explore, Neo4j Bloom, Data Importer, and Dashboards. Neo4 tools in Neo4j: Cypher Query. This tool is the primary interface for interacting with your graph using ciphers. Neo4j's Graph Query Language. It features a cipher editor with a syntax highlighting and suggesting a result frame that displays query outcomes as graph, table, or raw data. Neo4j can be used to build complex social media websites like Instagram and as well as LinkedIn, in which you are connected with people's. Neo4j Neo4j maintains graph databases that have nodes as well as edges for the relationship. Tools in Neo4j. Explore Neo4j Bloom. Powered by Neo4j Bloom offers a code-free visual way to interact with your graph and understand your graph. The main workspace in a graph scene where nodes and relationships are visually represented. User can drag and drop nodes with the right click for context menu and utilize overlays like a legend panel for styling, building relationship. The perspective of the drawer defines business data importer. This tools helps you to import your data from your CSV files into your Aura DB instance without writing a single piece of code. It represents graphical user. The person and the movie are the entities, and the directed and acted are the relationships in this particular image. You can upload your data files. You can give unique ID, constraint, indexes. You can map the relationships using nodes and nodes representing the entity and the relationship. You can see a dashboard. Neo4j dashboard enables the creation of custom dashboard composed of various visualization for quick overview of your data. User can compose different data visualization such as graph, tables, charts. As you can see in this image, this layout is flexible, allowing for arrangement and resizing of these components. This provides business analytics for a person using Neo.
To begin with the experiment, we'll first require an external dataset. The dataset we have selected is Netflix titles. We have pushed it to a public GitHub repository and copied the raw file link for further usage. It is important to ensure that the dataset that is being used is clean so that it doesn't give any errors. In Neo4j Aura dashboard, we'll first go to the instances section where we'll create our first instance. By clicking on Create Instance, selecting the free version, and writing the desired instance name, we'll create an instance. We'll have to copy the password. Also, the password gets downloaded on the PC automatically. Creating an instance takes a few minutes. Once the instance is created, now we'll have to define the queries to create the nodes and the relationships, for which we'll move to the query section present in the sidebar. Here, we'll first connect to the instance we have just now created. We'll select the instance 01 and connect to it. After we've connected to the instance, we can now define the Neo4j queries, and we can also see the nodes and the relationships present and the property keys. Write the queries to create the nodes and the relationships. We'll first load the GitHub file, the CSV file that we had copied, and then we'll ensure that the node that we are creating, in this case title, has no null values. We'll merge the title with the property keys such as title, type, release year, and rating, and we'll run this query. Running the query depends on the size of the dataset, and if the dataset is small, it takes milliseconds, but can go up to minutes if we are using a large dataset. Once the query, as we can see, the property keys has been defined. Also, the title nodes have been created as seen. Moving on, we'll create another node, which is director. So again, we'll load the CSV file from the GitHub, and then we'll create the director nodes. We'll run this query and wait for it to execute. So as we can see, the director nodes have been created. Now we'll do similarly for actors. We'll first load the CSV file and create the actor nodes. As this dataset was huge, a particular movie had a lot of actors, it took nearly 7 minutes to execute. Now we'll create our last node, which is the genre node, and after writing the query, we'll run it. So as we can see, all the 4 nodes have been created, and the number of nodes created for each has also been defined. Now we'll go on to create the relationships between the nodes. So the first relationship that we are creating is between the director and the title. We can say that a director of name this has directed a particular movie of title this. So we've again loaded the GitHub file and we've matched the director and the title to create a relationship between them. So the relationships between the director and the title has successfully been created, and we can see them in the relationships sidebar. Now we'll create the second relationship, which is between the actor and the title, where we say an actor of this name has acted in a movie of title this. So we've loaded the GitHub file and we've matched the actor and the title nodes, and we've created the relationships between them. Now we'll create our last relationship, which is between the genre and the title, where we say a title of this, or a movie title is of this particular genre. So running a similar query, we've created a relationship between the nodes. So we've successfully created 4 nodes, which are actor, director, genre, title, and 3 relationships, acted and directed and in genre.
Let us study Cypher queries. Cypher queries in Neo4j are the commands written in Cypher Query Language, which is a declarating language used to query and manipulate data stored in Neo4j Graph database. Think of Cypher to Neo4j as what SQL is to relational database. Like it is specifically designed to work with graph structures like nodes, relationship, and properties. Now we'll go through the easy syntax of the Cypher Query Language. We can represent nodes in curve brackets, the relationship in square brackets, and properties like key value pair in curly brackets. The Cypher commands like match is used to retrieve the data. The where and having like clauses are there. Then create commands are there to create the data. And we also have set and delete as in order to perform CRUD operations. So now let us perform few Cypher queries. Uh, in this Cypher query, we can retrieve the number of relationship and type of relationship which we have created. So we have acted in which genre the movie is and directed by whom, and how many relationships are there in each. In this query, we can retrieve how many total nodes are there in our database. So out of 37,338 nodes, we have 27,406 as actors, 6,234 as title, and the remaining as director and genre. And few more Cypher queries to see that to match the title and show in which year it was being released, along with the show ID. And we can also visualize graphs through Cypher queries. Here we can see the relationship with respect to the nodes. Here there are 50 relationship with respect to 48 actors and 7 titles. So if we zoom on any one of the graphs, we can see that in the movie Transformer Prime, these many actors were there. So also here we can see one of the relationship name as directed. Now we will perform a Cypher query which will contain all the 4 CRUD operation, that is create, update, read and delete. Here we'll create a new relationship with new type properties and deleting the old one. Here it will find the nodes that are linked by directed relationship. It will match and it will create a new relationship that is named directed by. It will um, copy all the properties from the previous relationship to this relationship and delete the previous relationship, hence performing all the 4 CRUD operations. We can see these much are created and these many are deleted. So this was the concept of Cypher query.
Any laptop.
So, this is the end of this lecture series. I'm really glad you stayed with me through all the session. If you learned something new, drop a comment below. I would love to know your thoughts and make sure you subscribe so don't miss the next series.